Okay, so for a horizontal launch, there's a few general concepts. I know I have pictures and I have the equations up there, but let's just take a look at the concepts for a horizontal launch. Just as for all projectile launching, the horizontal velocity is constant. So you can see up at the top how we have the horizontal velocity is at 5 meters per second, and it does not change. That's a key component. Another component is that gravity accelerates the object downward. Have your reference frame start at the initial position. And go down. Okay? Now, big piece is find the time the object is in the air. That's a big component. Okay? Using one of the base equations. Okay, now let's take a look at some of these base equations here. We know the initial velocity in x direction is constant, and we have all of these equations here on the right. Watch what happens. We're going to first of all put our reference frame positive and downward. Therefore, my initial position is at 0. Since I'm not putting any velocity downward, this whole term goes away. Okay, so just because, since these two are being multiplied, this will also go away too. So this whole term goes away. And then we can rewrite y equals 1/2 gt squared. But wait a minute, y is the final, it's going down, so it goes to whatever that total height was. Okay, so it's going to go downward. We have gravity being, depending on what you want to use, you could write 9.8 meters per second or 10 meters per second. Have the answer positive since you are doing down as positive. Okay. Now if you want to find the time in the air, so I'm just going to leave it as such so you can do all of these, whichever one you want. So if you want to go ahead and solve for t, so I'm just going to go ahead and box this one. So that's a major equation you'll want to use for later, just in case you already have the time. So a lot of times we want to solve for how long it's in the air. So how do we do that? Well, multiply both sides by 2, divide both sides by g, and we get t squared. Take the square root of both sides. It's the plus or the minus, but we don't care about what happened in the past, so we're just going to look at this. So the time is 2 times the height divided by gravity. That's how long the object is in the air. Okay, that's what we were just talking about a minute ago. Now, can we use how long the object is in the air to find out how far it goes? You bet. That's our other equation. So you notice how we just have 2 equations. I'll rewrite these 2 equations, these base equations. We have, I can write them out nicely. X equals times time. And then the other equation, and we have, we'll just say height because the displacement is the height in this case. 1/2, let's just say 0.5 gt squared. Okay, so those 2 equations, that's all you need. So you're going to use the height to find the time, and then the time could then give you either the how far it goes or the initial velocity. So I'll go ahead and put use the time to find the x or the initial velocity, depending on what you're looking for. That's it.